All right, ladies and gentlemen, good morning to all of you. Good morning, I guess. Is it good morning? We're in the morning still. Okay. Um, I'm gonna grade. I graded your what? I graded your guys' test three. You guys get it back today. So I'm gonna just remind people that the drop deadline is on the 7th because that's what the chair asked us to do, is to remind people of those things because sometimes students don't what remember, I guess, or they forget. So anyway, that's just a reminder. So letting you all know now, ladies and gentlemen, what have we been working with the past few days? I guess. Do you guys know? With estimation, is that true? All right. So what I'm going to do now for you guys this morning, we got at least 7 people at home. I'm going to give you guys what? A warm up. I'm going to have you guys do this particular question here, okay? Let's read it together. This is on astrology. You might say, what's astrology? I don't know. Study and belief of what? Stars, the alignment of stars. So here's what they're going to say to you guys. The sociologist gives a survey of 500 people on whether they believe in astrology and finds that 38.2% indicate that they do. Use the 95% confidence level to estimate the true proportion of people who believe in astrology. So I'm going to give you guys some time on this one as I go through a quick little email here to warm up. And there you guys go. Have you guys try this out. Okay, let's go through this. You guys remember this stuff from yesterday? Easy peasy lemon squeezy, because all it is what do I keep saying to you guys? Language and what? Process. Is that true? No. This is something that's probably, I should say, I don't know, it's definitely the point. Okay. So remember, what do they want you guys to estimate? They say to estimate a true proportion, right? So when you do that, what's the flag that comes up first? Okay. Isn't that the format that we're trying to do? We're trying to get a what now? We're going to try to get a lower bound value and an upper bound value for the true proportion. The true proportion is that P. So this is an interval estimate that they're talking about. Now, we've seen some examples of this, and they want us to take a what? A sample. Is that true? Now, what do they say? A sociologist gives a what? What are they doing? Giving a survey. What's a survey? That's a sample. And what do they give the survey to? 500 people. Is that right? So what does that 500 represent? That's what you have to know. You have to know. You got to read this. So, okay, what does that 500 refer to? What does that 500 represent? Sample size. Good. That's N. Is that true? All right. Sample size. That's N. So N is 500. Whether they believe in astrology finds that what? 38.2% indicate they do. What is that? What is that? What did they just give you? A sample what? Proportion. So the sample proportion here is 38.2%, ladies and gentlemen. So this is based on reading, is that right? Okay. Now, what's the confidence level? What does it say? Use the what? 95% confidence level. You go, oh, that 95% confidence level. So yesterday, as we've been doing this yesterday, confidence level is what? 95%. So I'm writing down all the information that we need. However, remember 95% is 0.95 and this is 0.382. Okay, for your sample proportion. However, what do you guys remember from yesterday? We seen this kind of situation yesterday. What was the problem? Yeah, we don't have X, do we? Because we're going to use the TI, and what function do we use? 1 proportion Z what? Interval. And that needs an X value. We don't have the successes. They gave us the sample proportion. So how do we get the X value so we can use our calculator? Yeah, N times what? P hat. That's right. So you say, oh, do I have to take the 500 and multiply it by the 0.382? What do you end up with? $500 times 0.382 382. X is 191. Is that right? 191 successes. Now, I wrote that down, okay, because I need that. Remember what I need? Here's what I need here. N, X, and what? The confidence level. Because I will be using 1 proportion Z interval. Okay. All right, ladies and gentlemen. So let's go to the TI again. How do we actually get there, if you guys remember? Right? What do we do to get there? Yeah, we got to go to stats. Is that right? So we go where? Go to stats. It's right here. And then we go to what? Tests. Good. And then we go down to, what do we go down to? 1 proportion Z interval right in there. So this is what you guys do. It's about you reading and then, oh, what happened? Did we do? No, we didn't do this one. That's not the one. Okay, now we got to enter X. What was X? 171. Okay, what was the sample size? Oh, 191? Yeah, you're right, 191. What was the sample size? 500. You guys are correct. What was the confidence level they asked? 0.95. That's all we have to enter. Hit calculate, and guess what? What do you get? What's the final answer, ladies and gentlemen? Remember this? It's the number on top, right? Isn't that going to be what? Point what? 0.339 is less than P, going to the nearest thousandths. Point what? 4 what? 5, okay? Now notice the sample proportion below. Was that our sample proportion below? Right? P hat, all that information. So you're reading this. So you got, ladies and gentlemen, what did we get? The lower bound value and the what? Upper bound value. This was the sample proportion, okay? But they already gave that to us when we read it, 38.2%. So this really is, ladies and gentlemen, what we'll be looking for, okay? This information. So this is everything that we need, and this is how you estimate. So the true proportion of people that what? They believe in what? Astrology is really somewhere between what? 33.9% and 42.5%. There you go. And isn't that what we did yesterday? Yes. Do we have to provide it in percentage? No, the probability is fine, but when I go back and do it, because like sometimes again, remember, why do we like the word percent? Because it's actually a way for us to communicate. So, you know, like if you ever even just listen to the news, they go, there's a 75% chance of rain. They don't say there's a 0.75 chance of rain. They use percentage. So all we're doing is looking back at it, and we're trying to communicate so we understand the meaning. It's not just computing these numbers, ladies and gentlemen. That's really not all of it. It's also about what? Understanding what they mean. And, you know, and this is like from the social science field. I mean, I guess it's fun to talk about all these things about astrology, right? Do you guys know what I'm saying? And I actually took some of these questions from various books, so you guys know. And now that leaves us what we want to do today. What I want to share with you guys today is we don't just estimate a what? a proportion, we estimate a mean. Now, what's a proportion, if you guys remember again? Let's ask you guys that question. Let me get some more coffee in me. Okay. Right? Like if I said to you guys, what percentage of you, oh, what? Well, does anybody here believe in astrology? What's your sign? What's your sign? Yes. Ooh, a Capricorn. Who do you align well with? Pisces? Who do you stay away from? I guess somebody believes in what? Astrology. Okay, how about this? What's a mean? Do you guys know what symbol is it for the true mean now? Because we want to estimate now for the true mean. We can do that as well. It's not just proportions. I can ask you, what's the mean number of scorpions or Scorpios that you've met in your life? And I gather data from everybody. And they go, oh, I've met 5. Oh, I've met 7. Oh, I've met 0. Oh, I've met 6. I'm asking for a mean now. I'm not saying it's a different measure. Is that right? But it has a very similar format. You guys know what this symbol is? What's that symbol? I gave that to you guys. That's the sample mean. Okay? What is E again? The margin of error. So what I can do, like for proportion, I can get the lower bound value and the upper bound values. So I can estimate an interval for the mean as well. Now, remember, technically, this is the margin of error formula. And this is going to be used for what we call a large sample, ladies and gentlemen. A large sample is any sample size that's what? Bigger than 30, by the way. That's the definition of a large sample. So back in the day, like before, we had to learn about the Z distribution. And this is your confidence level picture back in the day. You guys remember that? And then we had to learn all about the Z table. And this is going to be just giving you the different 99% confidence level, 95%, 90% confidence levels. They used to ask these kind of questions, and then we'd have to find these Z values based on using the table. This is the old days, not too long ago. If you look at some of my videos, I still have that. But we're going to now introduce you guys how to do this using the TI, not using the Z table. And in the past, we had to compute the margin of error formula. So in the past, we had to do a lot more work. So now we just use the TI. Did you see the proportion? Was that pretty easy, just entering 3 numbers? I hope so. Because I don't know how much easier they can make it. Unless I get students like that, Mr. Judge. My life will be over if I don't what? Pass this class. And then I go, oh my God, I feel the stress. I'm so stressed. Even though I failed everything and I don't turn anything in, my life's over. I say, oh, well, what do you want me to do for you? Do I take the test for you too? You guys know what I mean? What if I do the test wrong? I might do the test wrong. So you're going to need to do what? Some estimation homework, right? All right, well, let's do this. What do we say? It's language and process. What's the title of this? Years in what? College. Let me tell you guys a little something. Can I give you guys a little story? I know it's embarrassing, but I'm going to tell you guys this. It's not where you start, it's where you what? End. Let me say that again. It is not where you start, it is where you what? End. Is that true? These days, people are going to tell you things that if you don't what? Finish in 4 years, then they're going to say you are a what? Failure. And you want to know something? I would say to you, don't believe them. Why don't you believe them? You know how long it took me when I was an ELAC student? You know how many years I was here? Shh, don't tell anybody. It's embarrassing. I was here like 4 years. And then when I transferred, you know how long it took me to finish 2 years? 3 years. So what's the total? 7 years. Okay, you guys okay with that? Because it's not where you start, it's where you what? End. You know how long it took my daughter to finish a math degree? 4 years. What's the difference? Well, Mr. Judge had to do what? He had to take care of his mother. He had to take care of his grandfather. He got to take care of his little brothers. He had to go in the Marines. He had to work. He was a part-time student. That's all. He was part-time. Because Mr. Judge, you guys don't know the other part. It's going to make you cry. I had to sleep on the floor, ladies and gentlemen. I didn't even have a bed. I had a spot. And if somebody took that spot before me, I had to find another spot. I almost slept in the bathtub one time. I slept in the hallway. That's the way it was, ladies and gentlemen. So, yes, I had to work, and I had to do that. So it's not where you start, it's where you what? It's where you end. I believe in that. I don't know. I don't listen to what other people say. But my daughter, guess what? She didn't have to do that. She didn't have to take care of her father or her mother. She got to be a full-time student. She didn't have to work. She worked at the bookstore. Some of my students have run into her over at Cal Poly. And some of my former students, they go, Mr. Judge, I met your daughter. She's at the bookstore. Yeah, it's my daughter. She didn't work because she had to. She worked because she wanted to. There is a difference, ladies and gentlemen. So when you read this question, again, don't look at it and go, oh, because I don't look at it that way at all. I see the bigger picture. I see down the road. I don't see the small picture. I don't see something small. I see something big. So it doesn't matter where you start. It matters where you what? End. So in this example, what are they saying? Years in college, what does it say? A sample of what? 600 college students indicate it took them a mean of what? 6.5 years with a what? Standard deviation of 1.8 years to earn a bachelor's degree. Okay, whatever, that's fine. Use the what? What does it say? The 99% confidence level to do what? To estimate. Estimate what? The true mean years it takes to earn a bachelor's degree. Now, remember what I said to you guys. This is the format you guys use again. This is the traditional format for estimating a mean, yes, we're a large sample. They're going to be bigger than 30. It looks very similar to the one we already did. Very similar. So historically, you kind of tell people this. Here's the deal. Sample mean minus the error less than true mean. Less than the sample mean plus the error. We're getting, again, the lower value right over here. And you're getting the what? The upper value right over here. So the rest of this information, like before, you're going to have to take a sample. We did. So let's read the sample information. What does that mean? Let's go back and read it. You might have to read it over and over again, and that's fine. Right? Okay, you guys okay with that? So, what do you think that means? Sorry, I'm reading an email. A sample of what? What does 600 college students mean? What does that mean? That's your, what is that? In other words, what does that represent? N, good. What's N? Sample size. So you know what I'm going to put down? I'm going to put N equals what? 600. Okay. And then, what did they tell us? That there's a mean of 6.5 years. So what's the mean? 6.5. What else did they tell us? Standard deviation of what? Of 1.8. Is that right? So this is S. For sample standard deviation, we can put S equals 1.8. Okay. What's the confidence level? In that 99%? How do we write that as a decimal? Isn't that 0.99? Okay, ladies and gentlemen. Now, I'm going to use some common sense here. You say, Mr. Judge, what do you mean by common sense? Well, am I going to use one proportion Z interval? Say no. Why don't I use one proportion Z interval? We're not estimating a what? Proportion. What are we estimating? What does it say? Estimate the what? The true what? That's mu. That's mu. The true mean is mu. So, ladies and gentlemen, it's right in here. So, the point I want to make, because I've always had to say this to people, that, you got to read this to figure out what to do. And that's why I have to go through it this way to show you guys this. Now, what do we do with the TI now? Here's what we do, ladies and gentlemen. What does it say? We're going to have to use what here? This tells you what we do. You got to go to stat test, and then you go to Z interval. So I even give you guys the instructions on that sheet I've been putting in the comment section. Anybody go back and watch the videos? I hope so. Okay. Well, here's the deal. So you might say, okay, are the videos helpful? Okay, good. I'm glad I do it then. I'm glad. Here you go. Should we try this? Stat, test. I go to Z interval. Where is it? Oh, there it is. It's number what? 7. Do you guys see that there? It's number 7. Z interval. Press enter. Uh-oh. No, I think I'm going to enter stats. Go to stats. Hit enter there. And then you got to go to stats. Sorry about that, ladies and gentlemen. So make sure it's on what? Stats, not data. Put it on stats. Now, you see this first symbol? What is it? Uh-oh. What did I do? Stat, test, go down to number 7. Let's come back. I breathed on it. It's on stats. You see this symbol, sigma? That's actually the true standard deviation. That's going to be your S. So that's your S. You guys okay with that? What was S? What did we say S was? 1.8. What was the sample mean? 6.5. Okay. What was the sample size? 600. What's the confidence level? 0.99. And then hit what? Calculate. What do you guys think? What did you just get now? What are you looking at? You got the lower value being what? 6.31. Go to the thousands. What would that be? 1. Now that's less than mu, which is less than, go to the thousands again, 6 point what? 68 what? 9, ladies and gentlemen. So what I'm sharing with you guys is, you're going to read this. You get the lower value. You get the what? Upper value. And now you have estimate. These are not percentages. They're not proportions. These are means. This is estimated true mean mu. So what this sample is saying, it's going to take between 6.3 years and 6.7 years. Let's go out to the thousands. 6.311 years and 6.689 years. Based on a sample of college students. And that's kind of the email I'm working with right now with data in the state. All these kind of ideas that are used. That's what I'm trying to write down, all this data. You know. You guys okay with that? What do you guys think? Easy peasy lemon squeezy? So it's a different, what do we, maybe you want to write this down, okay? So it's in the notes here. We got to use in the TI, what do we use? Z what? I have my students, you know what they do? They write down Z interval when they do this. And how are you going to remember this? Stop and think about this, ladies and gentlemen. How are you going to remember what you really do? What's the secret to any kind of success? I'll ask you guys again, what are you good at? What are you guys good at? Anybody good at anything? What? What are you good at? So, Mr. Judge, I'm good at Call of Duty. I'm good at Call of Duty, PlayStation 5. How'd you get good? You practice? You imagine if you put the hours into this that you put into Call of Duty. Oh my God, you're going to major in math, ladies and gentlemen. You're going to major in statistics. You go, if I did that, because I just have to ask you, you know what's really heartbreaking to me? When I ask that question, what are you good at? And you hear students say nothing. That's heartbreaking. You're not good at anything? There's not one thing you're good at? No, I'm not good at anything. Are you sure? You ever think about it? Maybe you have to be good at something. What are you good at? There you go. That's what drives me crazy. Because, Mr. Judge, he does a lot of things. I even cook. I cook, ladies and gentlemen. You know what my daughter says? Dad, give me your recipe for this. Say, Ashley, I just found it online, and this is what I did. I followed directions. I say, here's the link. That's what you got to do. No, I want your recipe. You do something different. No, I don't. Yes. If there's something you want to learn how to do, you can do it. Follow your directions. These are your directions, ladies and gentlemen. And you practice and practice, and sure enough, now you're good. And you can do it blindfolded. That's how it works. That's how you get good at anything. Doesn't matter what it is. Oh my gosh. I don't know. I think I should have been a preacher. It's not too late. It's not too late. I'm going to be a preacher. Think anybody, if I preach online, what do you guys think? This drives me crazy too. Celebrity net worth? Wow. Celebrities have money? Something's wrong with this world. Let's read this. Celebrity net worth. What are they saying? A sample of 65 celebrities were surveyed and reported a mean net worth of $200 million. You know what I did there? I didn't put the big number, 200 million, okay? I didn't want to scare everybody. But, man, they took a sample of 65 celebrities and they found they took their mean net worth. That's 200 million. So let's read this here. That's a lot of money. Sample of what? 65 were surveyed, reported a what? A mean net worth of $200 million with a standard deviation of what? 20.5 million. That's your consistency, is that right? Use the what? 95% confidence level. Use 95% confidence level to do what? What are you going to do with that confidence level? To do what? To estimate the what? True mean net worth of all celebrities. There's not only 65 celebrities. There's a lot more, evidently. They took a sample. Okay? So I'm even highlighting the information with the colors I'm using. So this is estimating a mean. It's a true mean, right? So that's what? Mu. What do? You're going to write down what? Sample mean minus your error less than the true mean less than sample mean plus your error. So you're going to have a lower bound value and a what? Upper bound what? Value. That's what we're going to find. What do you use to do it? What are you guys going to use to do it in the TI now? Use what? Z what? Yeah. I'll show you how to get there, but yes. Okay, but we have to write things down. What do? Let's write this down. What do you guys do? What's the sample information going to be? Can you tell me what the sample size is? What's the sample mean is? What the sample standard deviation is? What's your sample size? What's the sample mean? I'm not going to put that big number, 200 million, but that number is in millions, just so you guys know. Maybe I'll put 200 M for millions, just as a reminder. What's the standard deviation? 28.5 million. And then remember, this is going to be the sigma. That's supposed to be known, but whatever. It's not really known. What's the confidence level that they told us? What did they say? 95%. I even drew the picture here for you guys. 95% confidence level. This is kind of the picture for the bowel, by the way. So we're going to write 95% how? As what? Here's 95%. It's what? 0.95. So, ladies and gentlemen, this is in your video. It's in your video in Canvas. You guys can go back and go, I forgot. I'm going to watch it again. Don't watch Netflix. You guys, I'm going to make my own app. What do I have to do now? Instead of Netflix, I'll call it JudgeFlix. Go to the TI-84 calculator. How do we get there? Stat. What else? Test. What else? Z what? Number 7. Z interval. What's the mean in this case? 28 point what? 5. What's the, I'm sorry, that's the standard deviation. What's the mean? 200. I didn't put all those zeros. I don't want to freak people out. 200 million. What was the sample size? 65. Isn't that a large sample because it's bigger than 30? Okay. What confidence level did they ask me to use? Point what? 95. And then hit what? Calculate. There's your answer. You're done. What's the answer? We're going to the nearest thousandths. What is this? It actually doesn't even give us a thousandths. But what are you going to write down? 193.07 less than mu okay, less than what? 206.93. So notice this, ladies and gentlemen. What's the lower value? 93. What's the upper value? What's the mean? Okay. Okay, you guys okay with that? And that's in millions of dollars. So I'm going to put a little M for what? Millions, just to remind people. Because what that is saying to you is this, because remember, it's not just that you read the numbers, you got to talk about the data. What does that mean? That means celebrities really, you know what they're worth? This is now an estimate on all celebrities. They took a sample. They're worth about between 193 million and 206 million. Really 207 million if you go to the nearest millions. That's a lot of money. You guys know what I mean? That's a lot of money. There's a lot of money in celebrities' net worth there. That should tell you something's wrong in the world with the world. I don't know about you guys. I see the bigger picture, not the smaller picture. I don't look at that and go, oh my God, let me be a celebrity. I want to be now Britney Spears. Would you want to be Britney Spears? I don't think I would. There's something wrong with her, I think. What do I got to do to be Britney? I don't even want to know. I don't want to know. But isn't that a lot of money? man, it's like if you thought celebrities have between 193 and 206 million dollars. I actually got this data from. It's actually somewhat realistic data, so you guys know. I got it from some book I can't mention. Got it from your textbook is what I did. It's from your I did textbook questions. Because you know what kind of questions I come up with. You might say, sometimes students want me to come up to do my own questions. And I do. I give you examples of those too. But I also do from the book. Because I think you learn a lot from the book. You learn a lot about, and this is just celebrity net worth. This is important, ladies. Don't you guys think it's important? You know what that means at net worth? That's how much money they have in the bank and property values. It's their net worth. Amazing. IQs of attorneys? This is IQs of attorneys, ladies and gentlemen. Are attorneys smart? Don't know. IQs of an attorney. Another book question. What does it say? It says a survey of what? 120 attorneys report a mean IQ of 108.6 with a standard deviation of 12.5. What do we use? What do they say? The 90% confidence level to do what? To estimate the true mean IQ score for an attorney. Now, this is all attorneys. They just took a sample or a survey of 120. There's a lot more than 120. So they're estimating what again? What's the parameter? A true mean. That is mu. You want to know that because you don't want to use the wrong TI, function. Is that right? You guys know what I'm saying? Can't do that. So let's write down the format. This is what I always do. I say, okay, what's the format? Format's going to be sample mean minus the error less than true mean less than the sample mean plus the error. And ladies and gentlemen, here's the deal. You need a lower value and you need a what? Upper value, because you're estimating what? The true mean. Now, here's the deal. You need to take a what again? You need a sample. You guys notice I always put my sample in red? Did you guys notice that? And I even highlight in red. It's all makes sense. So, how many attorneys are in the sample? So that's N. Is that true? Okay. What's the mean IQ score? What's this? X bar. What is it? 108.6. How do you know? Because they told you. They said, hey, that's 108.6. What's the sample standard deviation? S. And yes, that's your what? Sigma. That's really they assume you know it. That's the difference. That's a population. Whatever. You don't really know it, but okay. And what's your confidence level? So what do you guys write down? Confidence level. 90%, which is point what? 90. What do you guys use in the TI? At some point, maybe you want to write that down. Z what? Z interval. Is that right? You guys with me on that? Some point in time, maybe you guys say, I'm going to write that down. Write it down then. All right. Get out your TI now. Okay. And how do you get to the Z interval again? Go to Stat. Scroll to Tests. down to number 7, z-interval. Is it on stats? Yes. Okay. Now, what was the standard deviation? That's sigma. We wrote it down. What was it? 12.5. Okay. What was the sample mean? 108 point what? 6. Sample size, 120. This is 90%. Scroll down to what? Calculate. What do you end up with here? What do you guys know? This is the answer, right? 106 point what? 72 less than mu less than 110 point what? 48. Okay, so you found the lower bound value in this interval estimate, and you found the upper bound value, right? This is the true mean. You found the upper bound value, and there it is. So they're just estimating the IQs for all attorneys that, and you can say this with 90% confidence. Let's write that down too. You can say that with 90% confidence, use the confidence level. I'll kind of talk a little bit about that, but that the IQ scores are somewhere between 106.72 and 110. Average IQ score, typical IQ score of an attorney. Now, why is that relevant information? Right? What's the average IQ score of a person in general? It's 100. So what this suggests is that based on a sample that attorneys are what? Are a bit smarter than your average person is what they're saying. Because it's somewhere between 106 and 110. Really 107 and 110. Okay, that's they're estimating within a range of the mean IQ score for an attorney. So, okay, I don't know, compared to the typical, our average IQ of a person in the general population. Is that you? Anyway, let's make up another one. Give you guys another example. Let's try. Maybe have you guys try this. What do you guys care about again? We got to care about something. What do we care about? Ooh, anybody here on social media? What's your favorite social media platform? Who's on social media? What's your favorite? Okay. Do you have friends on Instagram, or who is it that you have? Is it friends? Okay. A sample of 250 college students reveal they have a mean of, I don't know, how many friends you guys have on Instagram? I'll say 120.8 friends on Instagram with a standard deviation of 35.2 friends. Use the 95% confidence level to do what? To estimate the true mean friends. Now, this is for every student. The true mean. Friends on Instagram. Okay, while you guys do that, I'm going to pass back your exams, okay? Let's see if I'm in the right class, but I don't know if I am. Alina Perry? No, that might not be it. No, I might be the wrong class. Juan Serrano? Okay, Juan. Good job. Natalie Kalajian? Isa Espino? Isa? Let me put that. On here. Okay, let's try this out. You guys ready to try this out here? What does that say, ladies and gentlemen? This is a what? Sample of what? 250 college students. That's N. Reveal that they have a mean of what? 120.8 friends on Instagram. Don't know if that's good. Standard deviation of 35.2. That's S. Okay, use the what? 95% confidence level to estimate the true mean. Okay, so I go through and identify all this stuff here. So I know what to do. And you say, okay, the true mean minus the error less than true mean plus your error, right? So write down your sample information. They told you the sample size is 250 and that the sample mean is what? 20.8. What's the sample standard deviation? 35.2. That's also sigma, lowercase sigma. And then they want us to use what? What's your confidence level? 95%, which is 0.95. Now, what do you guys use in the TI again? Z what? Z interval, is that right? All right. Okay, TI, let's get this going, TI. So we go to stat, test, go down to what? Z interval, okay. What's your standard deviation again? 35.2. What's the sample mean? 120.8. What's the sample size? 250. What's the confidence level? 95. Just fill this out. You're filling out a form. What's the final answer, ladies and gentlemen? 116 point what? 44 less than mu, less than 125 point what? 16. So, ladies and gentlemen, what you have now is the what? You got the what? Lower value. You got the upper value. And what does this represent again? This is the true mean number of friends that you have on Instagram. That's what they're looking for. The true what? Mean, ladies and gentlemen, okay? All righty. And you can say this again with 95% what? Confidence. We'll talk about what that means. So I would say to you guys, what do you guys want to get started on as soon as possible? Your homework. Because why? Because practice makes what? Perfect. You don't want to wait till the night before, because if you do, what's going to happen? You're not going to know what to do. You're not going to know your left from your right. Okay? Trust me on that one. That's what happens. Students wait till the night before, and then guess what? It's a nightmare for them. So get started ASAP. We're going to continue tomorrow with more estimation questions. We're going to estimate a mean with small samples. So please come back tomorrow because we're not done. See you guys later. Take care.